Good afternoon, students. Now we are learning our second unit, optics. Students, today I am going to make the topic of image formation for a spherical lenses. Students, we have light rays rule for spherical lenses. So in this video, we will be looking at three rules and how to apply them for our ray diagram. First, let us start with the convex lens. We know that the convex lens is a converging lens. For image formation, we need to draw the lens accurately. So I am going to show easy way of image formation. Let us first draw line to show the principal axis. Students, consider this is the line to show the principal axis and mark the optic center O at the center point. So this is the optic center O in the center of the line. So consider this is the principal axis and mark the optic center O at the center of the line. Students, by using the ruler, mark 2 points to the right of the optic center. So mark 2 points to the right of the optic center. Let us make it F2. F2. Take the F2 as 3 centimeter. 3 centimeter from O and 2F2. 2F2 is double the center, which means 6 centimeter from O. So similarly on the left side, mark 2 points F1 and 2F1. 2F1 from O using the same distance, 3 centimeter, 6 centimeter. Students, here F1 and F2 are two principal foci of the lens. So listen carefully, here F1 and F2 are the two principal foci of the lens. Now draw the convex lens at the center of the optic center. So here we are going to draw the lens, convex lens. Make it as a thin, don't draw as a thick lens. So this is a convex lens. So we know that convex lens is thick at the middle and thin at the edge. Students, before make our image formation, here we have to remember the rules for image formation for the convex lens. Students, we know that there are three rules for the convex lens. Rule 1. A ray which is parallel to the principal axis after refraction passes through the focus on the other side of the lens. And then rule 2. The ray of light passes through the optic center O of the lens goes straight without any deviation. And then rule 3. A ray of light passing through the focus after refraction become parallel to the principal axis. Students, rule 3 is exactly opposite to that of rule 1. It is due to reversibility of the light. Students, when drawing a ray diagram, we need to draw two rays from the point of the object. So we can choose any two rules out of the three. Students, when object placed beyond C. So here I am draw a picture. So consider this as a picture. Here I am draw a picture on the principal axis. So this is the principal axis. So beyond C or 2F1. So we need to consider a ray from the top of the object. So here this is the object. Also I can mention here as the arrow mark. A, B. So we have to consider the ray from the top of the object. So remember, we have to follow any two rules out of the three. So a ray which is parallel to the principal axis. So rule 1, a ray which is parallel to the principal axis. After refraction by the lens passes through the focus. So this is focus, principal focus. So a ray which is parallel to the principal axis. So after refraction by the lens, what lens we using? Convex lens. So after refraction by the lens passes through the principal focus. So this is focus. And then this is our first ray. So this is our first ray by using rule 1. And then for the second ray we have to use rule 2. The ray which is passes through the optic center O. So a ray which is passes through the optic center O goes straight through without any deviation. So what is the intersection? So this is the intersection. So two rays here intersecting. So what is the intersection of these two rays represent? Students, that is nothing but the image. So the intersection of the two rays is nothing but the image. So students, it is the image of the object which drawn by me. Students, before going to the next step, you must know the properties of an image. So first property, whether it is real or inverted, virtual and upright. So first property, whether the image is real and inverted or virtual and upright. And then is the image is magnified, diminished or same size, whether it is big size or small size or same size. That is second property. And then third property, so the position of the image, where it is placed. So there are three properties of the image, whether it is real and inverted or virtual and upright, and then whether the image is magnified, diminished or same size, and then third one is position of the image. So what are the properties of the image here for the case 1? Students, the image is real. So here the B dash, A dash is the image. So the image is real, but it is inverted. See here, the image is given as inverted when compared to AB. AB is nothing but object. And also the image is diminished. Students, as you can see, the image is formed between F2 and 2F2. So the formation of image position also important. The image is formed between F2 and 2F2. Students, in our textbook, the object is usually shown with a up arrow. Since the object is upright and marked as AP, and then similarly the image is also shown with an arrow, and it is represented as A dash B dash. As you can see, the arrow is inverted here because the image is inverted. Our next case, when the object is placed at C. So draw a line. Students, draw a line to show the principal axis and mark the optic center O in the center of the line. Students, from the right you have to take 2 points, F2 and 2F2, and the left side you have to mark it as F1 and 2F1, and from the optic center O you have to draw the convex lens. Students, here we going to place the object at C. So C is nothing but 2F1. So here we going to place the object A, B, up arrow mark is mean for object A, B. So here we going to place the object at 2F1 for our case 2. So once again we need to use 2 rules out of the 3. So first rule, what is the first rule? The ray of light parallel to the principal axis. So this is the line principal axis. So the ray parallel to the principal axis, after refraction it passes through the focus of the lens, focus of the other side of the lens. And then second rule. So what is the second rule? When a ray passes through the optic center O for the ray 2. So when a ray passes through the optic center O without any deviation, so without any deviation it passes okay. Students, when an object is placed at the center of curvature, the real and inverted image is formed. So the real and inverted image is formed on the other side of the center of the curvature. So the size of the image is same as that of the object. So the size of the image B dash A dash is same as that of the object A and B. Students, this is a picture to show the when object is placed at C. So the left side of the lens AB is for object, and right side of the lens B dash A dash is for the image. So when we place the object at C, so the image is formed on the other side of the C, so which is nothing but 2F2, and the image is real and inverted. and also it is same size. Our next case, when the object is placed between F and C. Students, draw a line to show the principal axis. So this is the first step. You have to draw the line to show the principal axis and then mark the optic center O in the center of the line, and then mark 2 point F1, F2 and 2F2 to the right of optic center, and then left side mark 2 point F1 and 2F1 to the left of the optic center, and then you have to draw the convex lens at the optic center O. So this is the first step. Now we are going to place the object between F and C. So this is the F and C on the left side of the convex lens. Consider AB. AB is the object. Students, we have to follow the two rules. So our first rule, the ray which is parallel to the principal axis. A ray which is parallel to the principal axis, after refraction it will goes through principal focus on the other side of the lens. And then rule 2. So when a ray passes through the optic center O without any deviation, it goes on continuous. So here the two rays are intersect. So this is the point. Here we will get the image B dash A dash. Students, when an object is placed between center of curvature C and the principal focus F, a real and inverted image is formed behind the center of curvature. So behind the center of curvature C, and then the size of the image is bigger than that of object A and B. Students, this is a picture to show the object placed between center of curvature C and the principal focus F. So here a real and inverted image is formed behind the center of curvature C, and then size of the image is bigger than that of object. Students, next case, when the object is placed at the principal focus F. So what is the first condition? So you have to draw the principal axis. So you have to draw the principal axis and mark the optic center O and mark 2 point F2 and 2F2 to the right of the optic center, and then mark F1 and 2F1 to the left of the optic center, and then you have to draw the convex lens at the optic center. Now we are going to place the object at the principal focus. So principal focus F. So we are going to place the object here at F. A, B. So you know the next step. What is the next step? So we have to follow the two rules out of the three. So first rule, the ray which is parallel to the principal axis after refraction, it will goes to principal focus on the other side of the lens. So this is the first ray. And then second one, when a ray passes through the optic center without any deviation, it goes on continue. Students, in the case when object placed at the principal focus F, the real image is formed at infinity. So the real image is formed at infinity. The size of the image is much larger than that of the object. Students, this is a picture to show when object is placed at the principal focus F. So when an object is placed at the principal focus F, the real image is formed at infinity. So the size of the image is much larger than that of the object. Students, this is the final case where the object is placed between the principal focus F and the optic center O. Students, let's use the rule 1 and rule 2 to draw the light rays from the top of the object. So here we place the object A and B, top of the object. As you can see, the refracted rays here are diverging. So divergent, so we need to produce them backward. So backward to obtain our image. Students, the image is magnified here. So the image is virtual. Virtual meaning straight image. So the image is virtual and erect. So it's magnified. See, when you compare to object, so A and B are object, A dash B dash are image. So image is straight upright, so which is direct. It is not inverted because here A dash B dash is given. So the image is direct straight image. So the image is magnified here. The image is virtual and erect and it's magnified and it's formed behind the object. That's very important. It's formed behind the object. Students, draw formation of images by convex lens when the object is placed at a various position in your classwork, and also practice by your own. Thank you. Have a nice day.